Hi guys, today we're going to talk transformers. So yeah, I've got some stuff here in front of me. First of all, a transformer will only work on AC current. So you see I have today, instead of a battery, I have a little power supply and I'm hooked up to the AC part. I'm only running a few volts. I have it hooked up. This is two solenoids. They are plastic lined. They do not have any metal connections to each other. They just will be one inside the other. I'm going to call this guy inner coil and this guy's the outer coil. Right now, I have the electricity hooked up to the outer coil. I'm going to bring in a meter. Hopefully we can all see. Just moving some stuff. There's a lot of wires here right now. And I'm going to take some measurements on the coils. Let's see if I can get this. Maybe we can do this way. It might be a little easier to see. And we'll leave this like this. So I'll reach around a little bit. So I have electricity hooked up to the outer coil, and I'm going to read how many volts there are with my digital voltmeter. All right, looks like I'm getting about 1.9 volts. Now, it is not in any way hooked up to this inner one, but because it is in here next to it, I'm going to be able to get a reading. Not a lot. Let me get it solid here. About 0.072. So I know that's not a lot of voltage, but the fact that I'm getting anything on there, it's kind of curious. How can I get electricity from this one to this one? Well, this is called mutual inductance. It turns out that when I have a magnetic field with AC current, remember what happens in a solenoid? When you send current in it from a battery, it makes a north and a south pole. But because this is literally changing north, south, north, south, north, south, and back and forth, it's called a changing magnetic field, and that induces a field over here. I can insert like a metal rod, I'm doing here. Again, that's just a screensaver. It's not really recording anything. And I'm going to get now 2.9 volts on that coil. And now I'm up to half a volt, many more times. This coil is still not hooked up to anything. It is simply next to this one. It is being mutually inducted. You want to know how your cell phone can have a wireless charger? This is how it works. I'm going to move the power to this little inner coil. I'm just going to have it go on the small inside one instead of the outside one. So let me move these around a little bit. This is called a transformer. Move these so they're not touching. I'm going to take the metal rod out. All right, so all I did was change the power. Now there is power on this middle one. It is in no way connected to this outer one, and it's simply inside of it. So if I measure the current, or excuse me, the volts on this one, sorry, I gotta do it this way. I gotta move my hand in here. I'm getting about 0.47. And again, this one's not hooked up to anything. It's just near, and I'm getting 0.13. If I put in the metal rod, without breaking everything, now I'm up almost tenfold. I'm up to 1. There's no electricity going on this, and yes, I'm getting a volt. And on this one, if I can hold it still, I'm getting about 0.6. All right, so the idea of this is that it is called a transformer. It is formed by mutual inductance, meaning that literally, I'm just going to unhook these and turn this off so that you don't have to hear that anymore. This is the basics behind how we can change a lot of our voltages from one thing to another. I'm going to bring this down a little bit. You don't need this power supply anymore. They are no way connected. It is totally, I know it's black in there, but it's all plastic. There's no metal connections. All that had to be done was to be inside of each other, and as long as AC current was in here fluctuating, it caused current to flow over here, and I was able to measure voltage. And if I put the metal in, it makes it stronger. So, where do we get transformers? Well, there's actually a lot of them. Maybe you've seen a plug at your house like this, right? These kind of plugs. Well, when you open them up, you'll see a metal core. What they actually do is they put the metal core around, and on the inside, I know you can't see them exactly, there's 2 coils of wire. There's one. There is one on here. This was another plug that I took apart. You'll see that it says on here, if I can bring it up and see it myself, it says input AC 120 volts, 60 hertz, 7.8 watts. The output is 9 volts. This transformer takes 120 volts and drops it down to 9. So whatever device this was that I used for a plug, it transformed it to 9 volts. Some transformers, this is sort of one you can see, again, the coils of wire are inside. They don't always wrap them on the metal, but there's a lot of metal here. It was a hookup for an input, and it had multiple different outputs. That was for a, what was it? It was an air conditioner that died on me. Maybe you recognize this guy. Little charger block. Oh, I wish I could see those numbers. You'd have to get in really close, but it'll tell you how many volts. Most of these work for 5 volts. You plug this into 120 and the output is 5. That's what most phones use. So transformers are all around us. Now let's get into the notes. I'm gonna put these wires out of the way. Zoom in a little bit. Adjust a couple of things here. There we go. All right, so when we draw them, they tend to look a little bit like this. First of all, it's called mutual inductance because you have to have 2 coils, usually inside each other or next to each other on the metal like you saw on the ones I showed you. It has to use alternating current. It has to be placed on the wire, causing a changing. It's a fluctuating changing field. It will not work with DC current. If you were to hook it up to DC, it'll work for like a second when you turn it on, and then a second when you turn it off, and that's it. You put another coil nearby, like the one I had was inside. The number of turns on each coil is what helps change it. So a primary coil is the coil that you either call input or the one that's hooked up to a power supply. Most of the stuff you have at home plugs into 120 and changes it, like that charger block. The secondary is what you're hooking it up to. So like when you use your charger, it goes out to your phone and it uses a different voltage. If you have one that increases, like this picture right here, this is the primary coil. It has 1, 2, 3, 4, 5, 6, 7, 8 coils. 1, 2, 3, 4. It steps it down. So this is going to turn voltage down, and actually it'll cut it in half because there's half as many coils. A step up, if you were to reverse this, would increase. Now there's no magic to this. You can't magically get voltage and current. There's a trade-off. When you have a step up transformer, you will get more voltage on the output. For example, fluorescent lights that are in your ceiling, like in the school classroom ceiling, they usually need about 1,000 volts. So, you know, they go from 120 to 1,000. But that changes the current. The one thing that stays constant, at least in the ideal transformers, is the power. In this picture, it's a step down. You will decrease voltage. So the up and down bases on the voltage, but the other will do the opposite. So if I decrease voltage, I will increase power. So there's this little 3-way kind of formula. Number of primary turns to the secondary is a direct relationship for voltage primary to voltage secondary, but it's an inverse. Notice that's an S. That's a really big deal. I don't know how many times people mess up and they put the P and the S in the wrong spot on current. They are opposite. So in ideal conditions, well, of course they're not ideal. Anytime you've ever used a plug like this, plug one in. You got one in your house? Go feel it. It's warm. You can see, here's one. It says class 2 transformer. Input 120 volts AC, 60 hertz. It comes out as 12 volts and 1,000 milliamps, which is just 1 amp. So I don't know how many amps they didn't put the input amps on there. You can see what it changes. So that one changes it from basically 120, it's 10 times different. All right, so let's do this practice problem. I'll grab my calculator. All right, so I have a step-up transformer. First, I want to know what's a step-up. It has 30 turns on its primary, so that means number of primary is 30. And 90 on its secondary, so number of secondary is 90. They could also call this input and output. The primary voltage is 10 volts. All right, I'm gonna move some stuff around here so I can use this. All right, so we're gonna use this ratio, but we're only gonna use the parts we need. I'm not dealing with current right now, so I'm just gonna use those. So I'm gonna have 30 over 90 equals 10 over VS. And the easiest way to do these is just simply cross multiply. Let's do it. So 90 times 10 equals that, divided by 30, but you could already figure out it's a 1-to-3 ratio. VS is 30 volts. Get my paper up a little bit. All right, the secondary current, so that means IS is 5 amps. What is the primary current? All right, so IP is my question mark. When I go to the formula, it's a three-way formula. I'm gonna generally not use something, you know I say this all year, if I had to solve something, I'm not gonna use it. So I'm gonna use this because I know it. So I'm gonna use NP, so I'm gonna have 30 over 90. And remember, the S goes on top now, so it's 5 over IP. All right, so cross multiply. 90 times 5 is 450, divided by 30, it's gonna be 15. IP is 15 volts. Again, primary could also mean input. And then what is the power in each coil? Well, so the primary coil, remember the power formula, P equals VI, is gonna be V primary times I primary. So let's see what that is, okay. V primary was 10, I primary was 15, so I get 150 watts. If I do it on the secondary coil, okay, it's VS times IS, so let's go. VS was 30, IS was 5 times 30, well, it's 150 watts. Shouldn't matter which one you do it on, they're gonna come out the same. That's the beauty of transformers. All right, we're gonna be doing some practice problems. See ya.